Hey guys, welcome back. So I hope you are liking it so far. We're just adding more things incrementally. I didn't want to really start typing some code right from lecture one. The concept is to see if we can slowly keep adding more and more stuff into it, and slowly we can introduce the concept of machine learning. All right. So now we know about algorithms, at its types, and its categorization, and things like that. But one of the things which kind of I keep repeating is this diagram, right? You have the input data and then you supply it to machine learning algorithm, and that will actually give you patterns predictions. Now I will keep repeating this as we'll use the same approach and keep adding more and more stuff to this. All right. So for us to start with our first machine learning implementation, right? We need some data set, right? And generally data set will be depending upon your business problem and your domain knowledge, you will gather the data set. But let's keep things very simple for now. Let's kind of take a data set which is readily available, publicly available, and we'll apply some algorithms to it, right? So in that way you at least know how things work, and then we can start taking some examples where we kind of take some inputs, modify it, and so on and so forth, right? So one of the data sets that's like commonly available, and any machine learning book that you take, you might find a reference to this. It's called as the iris data set, right? Now basically this is nothing but 50 rows of data, right? And iris, basically there are three species of iris that's basically mentioned in this particular data set, right? So what they have done is they have taken some measurements, basically the length and width of the sepals and petals, and then depending upon those measurements they basically say what type of iris it is, right? What is the species? Is it a iris setosa, virginica, or versicolor, right? So if I actually, there's a Wikipedia link, let me open that for you, and it kind of explains some history behind it, but the data looks something like this, right? So basically, as I said, it has about 50 rows in it, and it has more than 50 rows in it, but anyways, so these are the different species, and what we see in this particular data is the sepal length and sepal width, and petal length and petal width, right? And depending upon those measurements, the species is identified. So the concept is, as we have kind of discussed before, is if we supply this data to a machine learning algorithm, and in future if we get a particular iris sample, can we kind of looking at the pattern of its length, width, and petal length, width, can we kind of identify what type of iris species is it? So that's the whole idea behind it, right? So definitely read through this, some rich data set over here, and they'll give you some information on the history as well. All right, so I guess it should have, I believe, 150. So basically I think it's 50 samples of each of those species, right? So yes, so it's not total 50, it's 50 per sample. Okay, all right, so now let's see how can we download this data, right? So let me go ahead and just Google this iris data set download, and let's see if there is something publicly available. All right, let's take this, right? So this has this publicly available data, and one thing is, if you kind of use this website, there is tons and tons of data set that you can kind of use it in practicing your machine learning algorithms as well. All right, so let's go ahead and see if we can kind of download this data. So data folder, yeah, we have iris data, and this looks like let me actually just copy the URL and let me launch a notebook. All right, so we are going to probably open the same you know notebook that we created yesterday, that we practiced. All right, so what I'm going to do over here is I'm going to add a couple of cells. And first thing is that we can look at the data, and the way we can look at this is, if you remember, I mentioned that just read a little bit about modules, functions, and stuff like that. So I'm going to basically write some code over here to visualize the data, right? So data is coming from that particular download URL link that I have copied to my clipboard. Just set copy link address. And the way we are going to do that is we're going to say from ipython.display, I want to import HTML, and I'll say HTML followed by the URL that I just copied. And what I'm going to do is I'm going to press Control and Enter, and it's kind of going to download the data from that URL, and it's going to display it in line. Now this is where I said that it's really powerful, right? With minimal amount of code, you can actually directly download something from a URL and start to work with that data. And again, if you want to like format it a little bit, that's also totally fine, and it goes the same way. You don't need to write this again, but just for simplicity, display import HTML, and I'm going to say HTML, and then you can just format it as a normal HTML. So I can just say something like iframe, the source should be my URL, right? And that's it. Put in an iframe. Hopefully this should work. All right, so it kind of formatted that. All right, so we now have kind of played around with it, how to look at the data, but let's take a little bit of a deep dive into the data as such, right? The reason being that we really need to understand certain terminologies that we will be using throughout. So this is how our data is looking like, right? And in future, what we'll do is we will call the number of rows here as observations, right? As the English word observations, you have each row is an observation. So these rows are called observations. The columns, the input that we have been referring to so far, we'll be calling it as features, right? And the target is these values, the iris PC values. So three terms which we'll be using: your observations, number of rows, your inputs, that is called features, and your predictions or outputs, that we'll call as targets, right? These are the common input terminologies we will be using throughout. All right, so if you kind of relate it to our input sample, our iris data sample, your input data, that is sepal length, sepal width, petal length, and petal width, which you will be supplying to an algorithm, these are called feature names, right? And the output data, these are called as target names. Okay, so just keep in mind about those two things. All right, so moving on. So now you need to remember two main things which will be used throughout this course, right? Number one is you need to pass your inputs and outputs as different objects, and Python calls this as NumPy array. So don't worry too much about it. We will look at an example just after this. NumPy is nothing but an inbuilt packaging system. Just imagine it as an array, but it's optimized for faster processing, right? And the second thing is all your inputs and outputs that you give it to an algorithm should be numerical, right? But that's tricky because these things are numerical, but what about the outputs or targets? They are not numerical, right? So what we can do is we can simply assign some numbers to it, right? We can call setosa as zeros, versicolors as maybe 1, and so on. And the good thing is that Python will actually do this for you. And we'll look at it, just in a short while. We'll look at all those things. All right. So Having said all of those things, I would just like you to take a small pause and go through these reading materials, right? Because these are the concepts that we will be using. We'll be using NumPy, and we'll be using the two things that we discussed, right? Your inputs and outputs in a NumPy array, and then making sure that the inputs and outputs are converted to numerical form, and then supplying it to an algorithm. That's precisely what we'll see. So if you see the diagram, I have changed it a little bit. Now I want you to just take a guess on why we used an uppercase X and a lowercase y, and submit your answers in the forum. In the next lecture, we'll precisely use that and directly start coding. Thank you.